In this lesson, we're going to be looking at scatter plots, trends, and independent and dependent variables. And we're going to be looking at interpreting scatter plots and determining whether a trend exists. So the outcomes we're going to cover are describing the trends in the graph of a data set, including scatter plots, solve a contextual problem that requires interpolation or extrapolation of information, match given context with their corresponding graphs and explain the reasoning. Okay, a scatter plot is a graph of plotted points that shows the relationship between two data sets. You see a graph just below here, and in this example, each dot represents one person's height versus their shoe size. And what you'll notice is that it appears as we go from left to right, as our height increases, our shoe size also appears to be increasing. A trend is the general direction in which values in a data set tend to move. So as we said, as the height increases, the shoe size appears to generally increase as well. So the trend in the data would be a positive trend, we would say, where an increase in one variable causes an increase in the next variable. And what are these variables? Well, we have an independent variable, which is the variable we are able to control. We are able to change ourselves. And that's graphed on the x-axis or the horizontal axis. There's also a dependent variable. And in the dependent variable, that changes as a result of the changes that occur to the independent variable. So when an independent variable is manipulated or changed, the dependent variable changes as a result. And we see the dependent variable is graphed on the y-axis. Here's our example. The scatter plot below shows Olympic men's weightlifting records. The independent variable, again the one we can control, is the class of the weightlifter, so the maximum size a weightlifter can have. The dependent variable is the one that changes as a result, is the mass lifted by the lifter. So we're going to use the scatter plot below to answer the questions that follow. And we're going to have that scatter plot show up in our slides, so you don't have to have it right there in front of you. So what is the approximate record lift for the 58 kilogram class? So if we're looking for the 58 kilogram class, we're going to follow the independent variables, which are the horizontal variables. The 58 kilogram class is this dot right here. Okay. In order to determine the approximate record lift for the 58 kilogram class, we're going to do something called interpolation. We're going to gather information from the data that we have in front of us. And to do this, we're just going to draw a line connecting our dot basically to the vertical or the y-axis, which you see here. So the 58 kilogram class appears to extend to the y-axis or the vertical axis at about 138 or 139 kilograms, give or take. So we'd say that the lift record for the 58 kilogram class is about 138 or 139 kilograms. The next question asks us how many more kilograms was the record lift in the 81 kilogram class than in the 48 kilogram class. So we have to find those two classes first. It's the smallest and the largest, which you can see here, they're circled. Okay, so once again, we're doing an interpolation of our data. We're using the data we have in front of us, and we're going to extend that information to our y-axis to find out what those values are. So here we go. I've extended lines from my data point over to my y-axis to find out where vertically these values are occurring. So my 48 kilogram class is at about 118 kilograms, and my 81 kilogram class, the record lift is about 188 kilograms. So the record was 188 minus 118, or approximately 70 kilograms higher. So a person who has a maximum weight of 81 kilograms has been able to lift 70 kilograms more for the record than someone with a maximum mass of 48 kilograms. Next is we're being asked to describe the trend represented by the scatter plot. As you move from left to right, or look at your horizontal axis, your independent variable, which is our class, we see that as we travel from left to right, it appears that the maximum weight or maximum mass that a person has been able to lift has been increasing as well. Our y values, or our vertical values, seem to be increasing as well. As we travel from left to right on our graph, our data values appear to be moving up and up and up in general. Not all of them are doing that, but the general trend in our data is that it's moving in a positive direction. Okay, so the trend in the data is a positive trend. As one goes up, so does the other. So as the weight class increases, so does the record lift in general. If there were a 65 kilogram class, how many kilograms might the record lift be? Well, again, this is an interpolation because we're dealing with numbers that are within the set of values that we have. We don't actually have a 65 kilogram class, but a 65 kilogram class would fall within the number of classes we have here, between 48 kilograms and 81 kilograms. So here is a line showing us where the 65 kilogram class roughly is. And by interpolation, we can see, if we extend a line from this approximately where it should appear in the data, you see here, a dot for the 65 kilogram class would be at about the intersection of the vertical and horizontal line. So our data point would be approximately right here. Okay, that means that for a 65 kilogram class, based on the trend we see in our data, that is one, as the class of lifters goes up, the weight class of those lifters, or the mass class of those lifters goes up, the mass lifted also goes up. So it appears that for a 65 kilogram class, the maximum weight, or the record weight lifted, or mass lifted, should be about 150 kilograms. So here we go. By interpolation, the record would be about 150 kilograms for 65 kilogram class. In the last question, we see that as the mass increases for the lifters themselves, the mass that they're able to lift has also increased. Could this trend continue indefinitely? Well, the simple answer is no. And the reason behind that is, at some point, we are not going to be able to get any heavier. At some point, we're going to have a maximum amount of weight that a human body can actually have. And we're also going to reach a maximum limit as to how much a person can lift on their own. So at some point, we're going to max out in both the weight classes and the amount of mass that a human can lift. We're not going to get someone that is going to be infinitely massive. Okay, so to summarize this lesson, we have a scatter plot, which is a graph with points that show a relationship between your independent and your dependent variables. It's a set of points. The independent variable is a variable that is manipulated or changed by us. We are the ones who can change it. For instance, in the example we had, the mass classes of the Olympic lifters as our independent variable. We are able to control what the maximum allowed mass is for each class. The dependent variable changes as a result of the independent variable. Okay, so we saw that if we allowed the mass classes to get larger and larger and larger, we're getting bigger and bigger people, which means that they're able to lift more and more mass. So the dependent variable changes as a result of changes in the independent variable. And the trend shows the general direction that values move in. So in our example, we had a positive trend, a general trend, where that is one variable increased. As our independent variable increased, so did our dependent. We can also have what is called a negative trend in our data, where as our independent variable increases, moves from left to right, we can see a decrease in our independent variable. And we can also have examples where there is no trend. As we travel from left to right on our independent variable, we don't see any correlation or any type of relationship between the increase in our independent variable and our dependent variable. And in our question set, we'll be looking at a few examples that relate to those things.